A few questions here. What I left out was, well, maybe you can tell me, what did I leave out here? What concept? Not choosing all of them. Here's something, 5 songs. How many orders can those 5 songs come in? You can use the fundamental counting principle and just count how many go in each spot. Or you can use the permutations formula. That's what I meant here. Permutations formula is n factorial over n minus r factorial. Or in other words, the arrangements of the ones of all of them divided by the ones you are not choosing. Since here it says you're how many permutations of all the songs. It doesn't say all, but you have to assume it's all the songs unless it says otherwise. You're choosing 5 from 5, right? Choose 5 from 5 where the order is important. Order important. I know that now everything the order is important in here, but for later on it matters. You use that, the symbol you use for that is 5p5. The formula is n over n minus r. In other words, 5 factorial over 5 minus 5 factorial. 5 factorial over 0 factorial. 0 factorial is just 1. If you're not leaving any out, there's no different arrangements for those. It's just 5 factorial or 120. Okay? Either way you approach this, fundamental counting principle or using that formula, you should come to the same number. If you're choosing all of them, the shortcut can just be, you don't even need to use the formula, it's just 5 factorial. This is going to be the same way here, 8 factorial over 8 minus 8 factorial. Right? Just 8 factorial. All the numbers, you can multiply it out. Suddenly then I have skipped things. I've left out again choosing less than the number of objects. Maybe we can make a problem 2b here. This could be 2a. 2b is, let's say if you're choosing, what if you're only choosing 3? What if you're only choosing 3 from those 8? From these? In that case, NPR would be, you have 8 objects, you're choosing 3. If you're using the formula, you're just saying it's 8 factorial over how many? The ones you're not choosing, 8 minus 3 factorial. Or in other words, 5 factorial on the bottom. 8 factorial over 5 factorial, the ones you're not choosing. You can put that in your calculator as is. There is actually an NPR button on the calculator. The math part is the hard part of this is the setup and the thinking part of this. The actual calculation, there's lots of different ways to do it. You can do 8. You can go to that, find this on your calculator. There is actually an NPR button. You could use the factorial, or you could do this. You just put that in, and it'll give you the number, 336. Or you can use factorial button, or you can do it the long way, 336. If you were going to evaluate this the long way without a calculator, just expand it. But you only expand it to the point of where if you're expanding this the long way, don't expand this all the way down to the bottom. Just expand it to the point where you can cancel it with the bottom. Leave that as factorial because this is saying 8 times 7 times 6 times 5 and every number below it. Because then on the bottom you could just, if you have 5 factorial, this and this cancel out. And then you just have, what do you have? Just those first 3 numbers. Okay, that'll multiply out to that. Or if you're just using fundamental counting principle for that. 8 things first, 7 things second, 6 things next. The answer isn't so important as the different ways of getting it. And there's more than one way of thinking about it. This is quite a jump in thinking here, especially when you first learned this. If I give you an expression like this and I want you to simplify it, it's you can approach it the same way. You just have to think about why I expanded this the way I did. Why did I expand the 8 here until I got down to the other number? Why didn't I expand the 5? Yeah, why did I choose 8 instead of 5 to expand? If it was 7 factorial over 11 factorial, which one would you expand? It's bigger, right? You expand the larger number. So if you're going to try and simplify this, you don't even know what the number is, but you can still work with it. You have to think about which one's the bigger number. Which one is the bigger number there? N or n minus 2? N. I mean, this would be equal to n minus 1, n minus 2. You just keep subtracting 1, right? N minus 3, n minus 4, ... right? On the bottom, this would be n minus 2, n minus 3, n minus 4, ... You don't know where to stop. What you can do instead of doing the ... is just stop at the one that's common to both of them and put a factorial symbol. That means all the ones below it. Because at that point then you can cross this off, right? That and that are the same, whatever they happen to be, and you're just left with n times n minus 1. I don't care if you multiply that out or not. I'm going to move this over here for space. You can write it like that, or you could actually multiply it out. It depends what you want to do. Okay, either way. You need to think here which one's the bigger number when you expand it. Sometimes grade 12s make silly mistakes and say n and n minus 2. This is more symbols, so it looks like it's bigger. Don't just think about which one you're expanding. You need to expand the one that's the larger number. This, I don't know why I did this, but you can solve this equation. It says pt2 is 42. You could solve it by guess and check, but that's not really the strategy I was hoping for here. But you could solve it by guess and check and just test on your calculators until you found what n is. What would your guess be? What do you think? What might you try there? Is it 7? Have you tried it? Maybe. No, seriously, I mean, you could do it that way. Is n 7? 7p2, does that work? Does it give you 42? I don't think so, because that'll end up being a pretty big number. 6? 5? Anybody try any of these things by guess and check? Should we pause while you're doing guess and check? People call it guess and check because they don't want to call it trial and error, because that sounds so negative. Trial and error. You're not really making an error. You're just trying things. Trial and check. I don't know. You're picking numbers and trying it. It is 7. Okay. Is it 7? In this case, I want you to realize that there's no other number that works. I do want you to know how to do this algebraically, though. Algebraically means expanding this thing. Okay? What expression could I write for np2? I have a hint for you. It's already written up there. What expression could you write for that? np2 you could write as n factorial over n minus 2 factorial. You could write that equals 42. You don't know how to solve equations that have factorial notation in them, but you actually do if you understood what we did up here. You could simplify this. You could simplify this the way that you did up there. You could make this n minus 1, n minus 2 factorial over n minus 2 factorial equals 42. What could I do in that at that point? Cancel all of that out, and then you end up with something. Track and field team.